All right, welcome. Over the next 5 minutes or so, we're going to climb what I call the innovator's ladder. And each step, each rung, is going to give you a powerful new way to think, equipping you with a toolkit to solve your toughest challenges. So let's jump right in. You know that feeling, right? You're just stuck, staring at a problem that feels absolutely impossible. It is so frustrating. But what if the issue isn't really the problem itself, but how you're thinking about it? What if you had a set of mental tools that could help you break through literally any barrier? Well, you are in exactly the right place. Okay, so first rung on the ladder, this one's all about understanding that there are two fundamental ways your brain can work. See, to solve really complex problems, you can't just stay in one mode. You have to learn when to be the judge and when to be the artist. So you've got the judge. This is your critical thinking hat. It's convergent, meaning it's all about analyzing facts, spotting flaws, and narrowing down your options to find that single best answer. Then you've got the artist. This is the exact opposite. This is your creative thinking hat. It's divergent. It's about going wide, generating a huge number of ideas, and just exploring all the what-ifs without judging anything just yet. And this visual just nails it, doesn't it? The judge uses logic to find the one right answer, kind of like a doctor diagnosing an illness. The artist, though, uses imagination to generate many possible ideas, like a wild brainstorming session. The real magic, the secret sauce to innovation, isn't about picking one or the other. It's knowing exactly when to switch hats. Okay, so we've got our two mindsets, the artist and the judge. That's great. But how do you actually put them to work in a structured way? You need a process, right? Well, that brings us to the next rung on our ladder. And here it is, the double diamond. Think of it like a roadmap for innovation. First, you discover. You go wide, you explore, you gather tons of information. That's your artist. Then you define. You narrow all that down to the one core problem you need to solve. That's your judge. Then you do it again. You develop, brainstorming tons of possible solutions. Artist mode again. And finally, you deliver. The judge comes back to pick the best one, build it, and test. What I love about this diagram is how it shows you the whole flow, the whole journey. You can see the pattern, right? Diverge, then converge, and then diverge, then converge again. You start with this messy problem, you go wide with research. Then you focus in on a sharp definition. Then you go wide again with ideas before focusing in on the final solution. It's this beautiful, elegant rhythm that harnesses both the artist and the judge. But you know, sometimes even the best process isn't going to cut it for those truly wicked problems. To get to the real breakthroughs, we have to climb a little higher. We've got to learn how to break the rules of normal linear thinking. This brings us to lateral thinking, and this quote from Edward de Bono just says it all, doesn't it? If you're stuck, hitting the problem harder with the same old approach is, well, it's just going to get you a deeper hole. The real answer is to stop, step back, and start digging in a completely different, maybe even weird place. And then you've got this other powerhouse idea, first principles thinking. This is famously used by people like Elon Musk. Instead of looking at what everyone else is doing, reasoning by analogy, you strip everything away. You boil a problem down to its absolute fundamental truths, the physics of the thing. Musk did this with batteries. Everyone said they were expensive, but he looked at the cost of the raw materials and realized, wait a minute, we can build these ourselves for way, way less. All right, we are getting near the top of the ladder now, and this is where things get really fascinating. We're going to tackle those problems that feel like a total paradox. Where improving one thing just makes another thing worse. Welcome to the world of TRIZ, the theory of inventive problem solving. So this guy, Genrich Altschuler, the founder of TRIZ, he did something amazing. He analyzed thousands upon thousands of patents and found that the most inventive solutions weren't just random flashes of genius. They followed predictable patterns. His huge insight? Creativity isn't magic. It's a science. And chances are your impossible problem has already been solved by someone, somewhere, in a different field. And this is the absolute core of TRIZ. Stop settling for compromises. A normal solution is just a trade-off, right? You want a safer car, so you add more steel, but now it's heavier and less efficient. An inventive solution resolves that contradiction. It finds a way to get both. You use a new material like carbon fiber that's both stronger and lighter. See? No trade-off. You get the best of both worlds. This little flowchart just lays it out perfectly. You're at a crossroads. Path 1 is the compromise. You improve feature A, but you have to make feature B worse. But path 2, that's the inventive leap. You figure out how to improve both A and B at the same time. That's the prize. That's what we're aiming for. Okay, final rung. We've talked mindsets, we've talked frameworks. Now let's get super practical. I'm going to give you a rapid-fire look at 3 incredibly powerful tools from the TRIZ toolkit that you can literally start using today. First up, the ideal final result. This is a mental judo chop to your own assumptions. Instead of asking, how can I make a better coffee machine? You ask the ridiculous question, what if the perfect cup of coffee just appeared? With no machine, no cost, no harm. It sounds like magic, but thinking that way can lead to real innovations like instant coffee or delivery services. Next, we have the 9 windows tool. This is so cool. It forces you to stop looking at your problem in a tiny box. You have to think about it across time. What was it like in the past? What will it be in the future? And across scale. What's the bigger system as part of? What are the smaller components inside it? This big picture view often reveals solutions you would have completely missed. All right, let's hit a couple of these inventive principles from TRIZ. These are like cheat codes for innovation. First one, nested doll, just like those Russian matryoshka dolls. The idea is simple. Place one object inside another. A perfect example, a telescopic camera lens, where the segments slide into each other to save a massive amount of space. Okay, next one, blessing in disguise. This is all about turning a problem into a feature. A big data center generates a ton of waste heat, right? That's a problem. But what if you use that heat to warm the office building next door? Suddenly, a harmful effect becomes a totally free benefit. Genius. And one last one for you. Asymmetry. So many things we design are symmetrical just because it's easier. But if you break that symmetry on purpose, you can often make things way better. The classic example is an ergonomic mouse. It's not a simple block. It's shaped to fit the asymmetrical curve of your hand. It just works better. So that's it. We've climbed the ladder, from the basic mindsets of the judge and the artist, all the way up to these advanced tools that resolve contradictions. You now have a seriously powerful toolkit for innovation. So the only question left for you is, what impossible problem are you going to solve first?